Hello, in this video I'm going to demonstrate how to perform an independent t-test. And by nature, the independent t-test is set up to compare two separate groups of people, two independent groups of people, on one numeric, normally distributed outcome. So in this example, we're going to be using sex as our independent variable. And we can see here we have two categories of this particular independent variable. And then we're also going to be looking at science scores. And so we want to compare these two levels of sex, male and female, on their science scores on a standardized science knowledge test. Okay, so in order to complete the analysis, we're going to go to the analyses menu, and we're going to find the independent samples t-test option. As you can see here, when you hover over the name, a little box opens up here that describes in what circumstances the test should be used. So again, we're testing the differences in a scale or numeric variable between two independent categories. Okay, so our first step is to add our dependent variable. So we click on the Add Modify button, and we're going to choose Science Scores as our dependent variable. And this is, again, a numeric variable. This is percentage correct on an exam. And we've already pre-screened this to be normally distributed, but as you'll see, Intellectus will also screen that for us to ensure we have a normally distributed outcome, which, as I mentioned, is an assumption or a precondition for performing this particular test. So I've chosen my outcome variable or my dependent variable, science scores. I click Confirm. I next need to add my independent variable, and that is sex. And then I click Confirm. And then I can click Calculate. So we're going to go to the raw output here. And so our hypothesis, our null hypothesis for this kind of test is typically that there will be no difference between the two groups, male and female. Another way to characterize this would be the t statistic that we calculate that is provided for us in the output would be equal to 0, which essentially means the same thing, is that there are no difference between the means of the two groups when we have a t-score that is close to 0. So the first thing we can look at is to confirm the normality of the outcome, and we can look at the Shapiro-Wilk test, and we can see because the p-value is greater than 0.05 or 0.01, depending on which criteria you want to use, so we can assume that the data is normally distributed. And we're also introduced to Levine's test, which looks at the variance between the two groups to see if it is equal. And that's another assumption for t-testing, is we have equality of variance between the two groups, which essentially means the standard deviations of our two groups are very similar. And when this value is above 0.05, we can assume that we have equality of variance. And in this case, again, we do. So we've met the assumptions. We can do the t-test if we have non-equality of variance, but we have an alternate t-statistic that we have to interpret for non-equal variance in a group, or in groups. But as you can see here, we have what we call equality of variance within our group, so we can evaluate this particular t-statistic. Now, as you can see here, if we look at the mean values of our science test, we can see the male mean is 83, the female mean is 85, so there is a numeric difference there, and along with the standard deviations that are reported. And then we look for the t-statistic, and you can see here this is a minus 1.8, and that's associated with a p-value of 0.073. So if we're testing this hypothesis at the 0.05 level, this is greater than 0.05, so in this case we would not reject the null hypothesis. And would say that the means are essentially the same. They are not statistically significant in their differences. And you can see also here reported Cohen's d, which gives us an idea of the magnitude of the difference that might be present. It gives us a sense of the practical or clinical significance of what we're seeing. And you can see the Cohen's d is small, considered small, so there really is not a magnitude of effect that indicates practical significance. The last thing we can evaluate is the confidence interval for the mean difference. So you can see here in this line of text, the mean difference is reported. So the difference between the means of the two groups, the male and female, is minus 2.2. And the confidence interval indicates for us the range of possible mean differences that would be present in the population that these two samples of people came from. So if the mean difference in our sample was minus 2.2, the confidence interval tells us that it's about 95% likely that in the population, the mean difference could range anywhere from minus 4.6 to a positive 0.213. Now, this is a fairly large confidence interval, which is typical for us to see when we have a non-significant difference. But another thing to notice is that the lower limit of our mean difference crosses 0. So the lower limit is minus 4 and the upper limit is 0.2. So that means 0 or no difference whatsoever is in our confidence interval, and that's another indication for us that we should not reject the null hypothesis. When we have a confidence interval that crosses 0 or has 0 within its range or limit, then we have a non-significant difference. So we could then conclude that there is not a statistically significant difference between these two groups, and the numeric difference we're seeing could be due to chance or some other explanation, and not because a participant is one gender or the other. So hopefully you've been able to learn some new information from this video, and good luck using this video in your own research.